Hi, welcome to MS Tower. This is Group Intile-Agent. For today, we'll bring you through our project component. Our group is comprised of this. So for today's agenda, we'll be going through the steps and how we arrive in our final code. Firstly, we'll be covering the introduction to this project, then followed by Agent 1 and Agent 2 specification, and their brief and the strategies of how they accomplish their task. Lastly is also how the agent communicates between themselves. And to end it off, we'll show a demonstration of our code in the three different environments and our experiment results. So first, what is a multi-agent system? So MES is a system composed of multiple interactive intelligent agents. And as agents are mostly self-interest, having more than one in the system will require them to be able to collaborate with each other. This can only be achieved with efficient communication system. So a bit background of our project. Tower is a two-agent in a three configurable environment. You have one common goal, it's just to score the highest possible point by collecting tile and placing them in hole. So to accomplish this, our strategy use communication to derive the most efficient solution. So let's start with Agent 1 architecture. Agent 1 follow a very simple architecture of practical reasoning. It begins by detecting by collecting new percept in every move and deliberates its option. From here you can see Agent 1 actually have three phases of design. In phase 1, it prioritizes exploring and refueling, so it actually roams free around, avoiding all the obstacles and going back to fuel. Phase 2 is rebranding of the action it wants to take. So first it replans the shortest path to nearest tiles and hole to decide whether it should take a tile or fill up a hole. And lastly, it set a communication with the second agent. So a bit more about Agent 1 code. Agent 1 act in 3 cycles, the think, act, and execute. So in a think cycle, there's 3 points to take note. First is the revised belief of what it must do, then it will generate the option, and then it will filter its intention to determine whether the plan is sound or unsound. And lastly, it will send a message to Agent 2. So first, how it generates option. So Agent 1 actually have a couple of steps. It decide whether does it have a tile or is there a nearby hole. If there is a tile and there's a hole, then it will, for example, if there's a tile and there's a hole, it will go and fill up the hole. Whereas if there is no tile, it will prioritize pick up a tile. So after it decides its option, it goes on to filter its intention to whether to check it out. So next is the filter intention function. In filter intention, it goes through this following step. First is its highest priority to decide whether it needs to refill. If the fuel level is good, you'll move on to see whether what was the previous intention, whether is it to pick a tile or to fill a hole, and you'll decide accordingly. Agent 2 is pretty similar to Agent 1 with a few small minor changes. So Agent 2 will have a more robust soundness check to decide what it must do. Also, it will defer to Agent 1 if it wants to pick a hole. A bit more about that. Agent 2 design is basically a two-phase design. In the first phase, it will rebrand after its soundness check. So after it decides to either pick up a tile or to fill a hole, it will brand its shortest path and decide how sound is that path. And phase 2, we call it the benevolent agent. So basically, it differs to Agent 1. So if you have the same goal as Agent 1, it will give up its goal and let Agent 1 execute it. So the agent have a set of common beliefs. So that first is the need to refuel. This is always true if an agent is running low on fuel. So if there's a need to refuel, you prioritize refueling above everything else. Next is tile picking. If an agent is carrying less than 3 tile and he has spare capacity, you prioritize picking up the tile. Following, after you have all the tiles, you try to fill up the holes. So this is only true if the agent is carrying at least 1 tile. And lastly, if you have no tile and no hole, you move on to exploration, where you just roam around freely to find the next hole on the next tile. So agent strategy. Start of the run, when we don't have any tile and hole, it begins the exploration phase. So you choose a random faraway location and move towards that direction. This allows the agent to explore a vast portion of the map versus in just moving randomly around. So this actually make use of the A-style algorithm to find the best path to that random location it determines. A-style algorithm, as you already know, is basically to choose the shortest path to reach that location while avoiding all the obstacles. This allows us to conserve the fuel, so it's able to perform much more action before the time is up. Next, when a tile is found, he'll check if the tile picking belief is true. If the agent decided to go and pick up a tile, it will interrupt his other plan, be it exploration, and move on to pick up that tile. So once he got a tile, you look for a hole. If there's a hole is found and we have a hole filling hole belief, which means that it's either there's no other nearby tile or you have carried up the maximum of 3 tile, you interrupt his other plan and go and fill up the hole. So agent carrying 1 or 2 tile. Agent can determine whether he wants to pick up a tile or he wants to fill up a hole if he has spare capacity and there's a hole nearby. So this is actually determined by the cost of the agent to the tile or hole. If the path to tile is lower than the path to hole, then you pick up the tile and vice versa. And lastly is the need to refuel. This is of the highest priority for the agent, and it will interrupt all other plans and go back to the refueling station. Plan will not change even if other beliefs are true, so this ensures that the agent will never run. Lastly is the agent communication. So as each agent can only see 3 tiles around them, it actually communicates what they see to the other agent so that the agent is able to have a more complete picture of the entire environment. So there are 5 types of communication. First is add tile and hole. Second, remove tile information. Third, remove hole information. Fourth, going to pick up tile. And lastly, going to fill hole. So firstly, when the agent detects a new tile or new hole, agent will tell each other about the location of the tile and hole that they saw, and also they update their own memory based on this information. Secondly, is the remove tile information. When the agent pick up a tile, it informs the other agent that he has picked up this tile and thus removing that tile from the agent memory also. Thirdly is the remove hole information. Likewise, when the agent fills up the hole, it informs the other agent that this hole has been filled and the agent removes the hole from his memory correspondingly. Fourthly is going to pick up tile. So when the agent determines that it's going to pick up this tile, it actually notifies the other agent that this is the target tile it's going to pick up. So there will not be a clash of interest where both agents go and pick up the same. And lastly is going to fill hole. Likewise, same as the pick up tile, it will announce the intention to fill up a hole so the other agent will not have the same. So after doing a couple of experimentation, these are the results from the 3 different configurations. In configuration 1, we have an environment size of 100 by 100, average object creation rate of 0.2, and sigma of a variance of 0.05, and a lifetime of 100. Configuration 2 is a bit smaller. We make use of an environment of 50 by 50, with a higher object creation rate and a lower spread, and a much shorter lifetime of 30. Whereas configuration 3 is a bit more unique. It differs from our normal square environment into a long rectangle, 300 by 25. You have a very low object creation rate and also a very low variance and a lifetime of 200. So as you can see, our agent performed the best in configuration 2. In a small environment and high object creation rate, is able to achieve a score of 667 versus configuration 1 of 76 and configuration 3 of 182. So do note the environment is running on the seed 40462015 with default field level 1200 and a default sensor range of 3. So next, we're going to show you the demonstration of our 3 environment.
Hi, we'll now show you a demonstration of our agents running in the 3 environment. So for environment 1, we have an environment size of 100 times 100, average object creation rate of mean 0.2, deviation of 0.05, and an expected lifetime of 100. So we'll now run the agents through a NetBeans Mason simulator. So as to not confuse you with what is actually appearing in the environment, we will turn off the agent's working memory. So as you can see, the 2 agents are running in the environment. The first agent is actually the red agent, and the second agent that we have designed is actually the blue agent. So for the first environment, it is set up to be big with scarce resources. This will mean that the likelihood for agents to find tiles and holes is actually very low, and they will spend most of their time exploring. As a result, we can actually predict that the average score for each agent in this environment is the lowest among the 3. Furthermore, we would expect that Agent 2 will score worse off than Agent 1 given how it's designed. This is because Agent 2 will always reconsider its plan if it's the same as Agent 1. So we will now skip through this video at a 3 times speed, and we'll once again come back to conclude the results at the end of the run. So we have reached the end of the run for environment 1. Agent 1 scored a total point of 47 points, and Agent 2 scored a total point of 25 points. This is as expected, given their design behavior. We'll then move on to environment 2.
This is the run for environment 2. The environment size is 50 by 50 cells with a mean value of 2 and standard deviation value of 0.5. The lifetime is set at 30. The agents scored the best in this environment. This is likely due to the smaller environment size as compared to the other configurations, and the tiles and holes are generated at a faster rate. Given this highly dynamic environment, the agents are able to find more tiles and holes much faster and thus score more points. In this run, Agent 1 has scored 339 while Agent 2 has scored 336. Now we'll move on to the third and last environment. This is the run for environment 3. The environment size is 300 by 25 with a tile mean value of 0.8, hole mean value of 0.2 and obstacle mean value of 4. The standard deviation values are 0.01, 0.002 and 0.2 for tile, hole and obstacle respectively. The lifetime is set at 200. The third environment is wide, meaning that the agents have a large space to explore. There are also more obstacles generated, while the holes are generated at a slower rate, which will affect the agent's scores. Hence, it is expected that the agents will not do as well in this environment as compared to environment 2. In this run, Agent 1 has scored 105 while Agent 2 has scored 79. We will now move on to the conclusion.
Okay, as you've seen, these are the results from our 3 different environments. In environment 1, the environment area is large, 100 by 100. So the likelihood of an agent finding a tile or a hole is much lower. Environment 2 performed the best for our agent as it's the smallest environment and the holes are generated at a much faster rate. This allows both agent 1 and 2 to be able to pick up tiles and fill up holes in a very fast rate. Lastly, environment 3 is a very wide and narrow environment. This means the agent has to travel a much longer distance to pick up a tile or to fill up a hole. And given the much slower object creation rate, the agent, as expected, performed more poorly. Now, for our conclusion, Agent 1 performed better than Agent 2 in all environments. This is as Agent 2 always make other plans when it coincides with Agent 1. As mentioned earlier, this is the benevolent agent factor, where Agent 2 differs its priority to Agent 1. Also, Agent 2 soundness check does not guarantee a better path to the closest tile or hole all the time. Hence, there are times where Agent 2 actually wasted more time looking for a tile or hole. Both agents perform better in a more dynamic environment versus a more static environment. This is as demo in environment 3 where the object have a much longer decay time.